Okay, going to look at some 5.1 problems here and how to use the calculator to find the areas under these normal curves. So in this first example, comes right from our homework, we want to find the area below a z-score of 0.85. So z-score of 0.85, remember what that means. It means they scored above the mean, right? 0.85 standard deviations above the mean. So we should expect our answer to be above 0.5, right? That should make sense. So we're going to use the feature on our calculator like we looked at in class. It's called NormalCDF. So most of the time in class, right, we're living in this stat menu. But right next to it or just below it is the distributions menu. So we had this for the binomial distribution, and we're going to use it a lot this week for the normal distribution as well. So we want to find the second button, and we're going to hit second and then vars for the distributions. And we don't have to go as far to find NormalCDF. We won't use NormalPDF at all, so don't even have to worry about using that. We do use the binomial PDF and binomial CDF. Both of those are useful for us. But for the normal distribution, we only use a cumulative distribution function. We're always finding an area under the curve with a lower limit and an upper limit. So in the first example that we looked at, the lower limit is basically negative infinity. So if we want to put in a really small number, now I want you to be careful if you use a negative sign. Make sure you're using this for a negative number. This subtraction sign is to do subtraction, right? If I wanted to do 10 minus 7. This is to indicate a number has a negative value. So I'm going to start that normal curve all the way at negative 100. Negative 10, truthfully, is probably far enough back. But like negative 10 would be 10 standard deviations below. There's really nothing, you're not going to get any difference between negative 100 and negative 10 because we know once we get to like 3-4 standard deviations, we've encountered pretty much all of the possible values. So I'm going to start all the way at negative 100. And if your screen doesn't look like this when you hit NormalCDF, don't panic. I know what it looks like, and I'll look at that with you as well. And then I have a mean of 1 and a mean of 0 and a standard deviation of 1. That's any standard normal curve is going to have a mean of 0 and a standard deviation of 1. So when I press enter, most of your screen probably look like this. So this is how you're going to parse this out. You're going to, when you type NormalCDF, you're going to get the parentheses. So you put your lower limit, comma, upper limit, comma, mean, comma, and then standard deviation. So some of you with the binomial last week were missing the commas or forgetting that step, so we don't want to lose that here. So I get an area of 0.8023, and that's sort of what we had predicted or thought. It would be more than 0.5. We know that, so we know our answer sounds reasonable. Let's see if I can remember what it was again. 0.8023. Okay. And that's our first example. So let's look at the next one. I want to work through that one with you as well. Okay, so number 9 is very similar to number 8. If we look at it, the only difference here is there's still an area under the curve, but notice now I want the area to the right of z equals 1.59. So the idea is still the same, function is still the same, it's just the way I'm going to put in my lower and upper limits will change. So remember the shortcut, if you want to make use of this, we can just hit second and enter, and it'll bring back up our NormalCDF if you don't want to have to go look for it. Okay. So this time, when you look at that graph, and you'll see that our lower limit now is 1.59. Okay, so I'm going to change this to 1.59. Okay, so my calculator's acting up, but so my lower limit is going to be 1.59 this time. So I just cleared my screen, so I'm going to go second vars, NormalCDF. My lower limit's 1.59. Upper limit now this time, we'll pick something really big, like we could pick 100. And we're still living in the world of a mean and standard deviation of 0 and 1. It's just the standard normal curve. Okay, we haven't translated to anything else. We'll do that in 5.2, where we apply the normal distribution to other means and standard deviations. So 1.59 to 100, and I get 0.0559. Good. Okay. So one more that I want to look at in terms of the standard normal curve. This is where we have an area bounded by 2 values, right? So now it should make it even easier, really. I have my lower limit, negative 1.5, my upper limit, 0.7. So if we use our trick, we go second and enter, then I don't have to go back into my NormalCDF menu. calculator locked up on me before last time I did this, so I'll try to be careful. So we want to go from negative 1.5 to positive 0.7. So remember, that's this negative sign down here. Negative 1.5 up to positive 0.7. Our mean is still 0 and standard deviation 1. So if I just delete that comma, I think I'll have everything I want. Let me just double check that's my right parameters. Yep. So that's 0.6912. Come back here, 0.6912. So it's really more of an exercise in communicating with the calculator what it is that you're trying to solve for and find. Let me take a look at number 12. I had that on my list here. Yep. So here I don't have a curve now, so I'm going to have to try to picture it if I can. If I can picture what this normal curve looks like, right? That would be helpful, and you probably have one on your formula sheet. So what this is asking for is the area to the left of negative 1.15. So where does negative 1.15 is going to be like right around here, and I want everything to the left of it. Okay. My lower limit now, if I want the area to the left of negative 1.15, my lower limit is going to be like negative 100, and my upper limit is at negative 1.15. So if I use second enter, and I'll go all the way down to negative 100. Okay, so we have negative 100 to negative 1.15, and then we give it the mean and standard deviation of 0 and 1. 0.125, if we round to 4 decimal places, that 0 is going to come up to a 1. So 0.1251. We're good on that one. So that's 12. And then a couple that I wanted to look at were graphs where we can try to make use of StatCrunch. So number 16 here, this is going to be pretty easy normal CDF. We're just going to go from 0 to 1.17. That's your lower limit, upper limit, right? 0 to 1.17. We go 0 to 1.17. Not going to take the time to look at that one. I want to jump to number 17 because that is a graph, and I think that StatCrunch will. We haven't looked at StatCrunch. Hopefully we'll look at it in class tonight, but it's built right into your My Stat Lab, so it can be really handy. The way we would approach this problem, right, we would put all these numbers in our calculator and make a histogram that way. We could make the 5 classes, but there's a lot of heavy lifting involved in that if we want exactly 5 classes. What I'm going to suggest you do is try opening this data set in StatCrunch and see what happens. When I open this up in StatCrunch, okay, it's another little technical difficulty. We'll do a couple of StatCrunch things this week just when it's more convenient. But if I go to my graph here and I select histogram, okay, the variable I want to highlight, and then I can just go ahead and click on compute, okay, and it makes a histogram for me, and I can see I have a pretty mound-shaped symmetric histogram. So when I go to the choices that are here for the problem, I can see the only one that makes any sense would be choice D, okay. So try using StatCrunch for the histograms when you get to those problems like 16, 17, 18, and so on. I think that'll help you out.